How an electric motor rotates. You will be able to explain it to anyone after watching this animation video. The motors, found in fans or other machines, are complex in their structures. Motor makers produce complex models to keep many factors, such as performance, power consumption, durability, etc., at an optimum level. Here, in this short animation video, we will learn the basic structure and function of a simple electric motor. Once you understand a simple motor, your idea of those complex motors will be made. In a simple motor, the two poles of a horseshoe magnet are placed very close to each other. The lines of magnetic field are always oriented from the North Pole to the South Pole. These green particles are pointing to the lines of magnetic field. Each motor has a loop-shaped, twisted, insulated wire. It's called armature. Armature typically may consist of multifold loops of wire. But, for the sake of simplicity, we have discussed a single wire armature here. The armature is held in such a way that its two functional arms, the red-colored arm and the blue-colored arm, always remain perpendicular to the magnetic field. Two semicircular metal sheets are attached to each ends of the armature wire. These semicircular pieces are called commutators. The armature is held tight by means of an insulated cylinder-shaped bar and two ball bearings, in such a way that the armature can rotate very easily. Two gas carbon brushes are placed next to the commutator. Brushes are placed in such a way that when one brush touches a commutator, the other brush will touch the another commutator. We need a battery. One end of the battery is to be connected to a switch, through a wire. Then, using another wire, the switch, and a carbon brush, is joined. Another wire is taken, to connect the other end of the battery to other carbon brush. A switching starts a steady current. This flow of current starts from positive end of the battery to switch. Switch to carbon brush to commutator, commutator to armature, armature to another commutator to another carbon brush, and at last to the negative end of the battery. Now let us see the functions of the commutators. When the rotating armature lays between angles of 280 degree, that is, -80 degree and +80 degree, the positive end of the battery comes in contact with the red commutator, and the blue commutator is stuck to the negative end of the battery. In this situation, through the red arm near the South Pole, an electric current will flow inwards, and, in the blue arm near the North Pole, electric current will flow outwards. If the armature rotates further, at angles between 80 degree and 100 degree, the commutators will lose connection with the brushes, and there will be no electric current to flow. Then, from 100 to 260 degree angle, again the connection will be established. However, the direction through the armature will be changed. Because of this, in the blue arm near the South Pole, current will flow inwards, just as it was in the red arm before. And, in the red arm near the North Pole, the electric current will flow outwards. In the previous instance, when the blue arm stayed there, a similar outward current was observed. Thereafter, the armature is rotated a bit to lay between 260 and 280 degree with respect to the horizontal line. And in this case, line is disconnected again. So, the current stops flowing. But, shifting towards 280 degree, that is, -80 degrees and up to +80 degree, will create a situation like the first one, and the electrical current will flow. So, we observed that, Rotation of commutators bring changes in current flow in the armature. It starts, stops and changes direction of the current, periodically. Also, note that, whichever arm comes closer to South Pole, its current will be inwards, and, the arm near the North Pole, will flow current outwards. These are the functions of the commutators. Parts of motor are roughly classified into two types: the rotor and the stator. The rotor is the parts of the entire motor that can rotate, for example, armature, commutator, cylindrical bar, etc. are rotors. And the parts that remain fixed are called stators. Stators are magnets, ball bearings, carbon brushes, wires, etc. When an electric current flows through a magnetic field, that magnetic field exerts a force on the current-carrying wire. The direction of the force can be determined by using Fleming's left-hand's rule. If we arrange our left thumb, index finger, and middle finger perpendicular to each other, and if the index is pointing towards the magnetic field, and the middle finger is in the direction of current, then the force will be in the direction of the thumb. And this force will push the electric wire to this direction. How does Fleming's left-hand rule drive electric motors? If the motor is switched on, the electrical current will start. Applying Fleming's left-hand rule to the arm near the South Pole, we will see that an upward force is acting on the arm. Again, by applying Fleming's left-hand rule to the arm that is near the North Pole, it will be seen that a downward force is acting on the arm. These two equal and opposite force act like a torque, and make the armature rotate about an axis. But once turned around, the other arm of the armature moved to the first arm's position. Besides, the commutators also changed their positions. As a result, the direction of the electric current reversed. It is now from blue arm to red arm. Note that, whichever arm comes closer to the North Pole, its current flows outward, and the arm near the South Pole has an inward current. In this new situation, the upward force acts on the blue arm of the armature and a downward force is activated on the red arm, for which the armature should turn again to go back to the situation as of the first one. Thus it continues rotating again and again. This is how motor rotates. Now, if you place a coaxial bar tightly attached to the armature, the bar will rotate on that axis. And if a fan-like blade is placed on the tip of the bar, the fan will rotate. Hoping this video to be helpful in generating a clear idea in you. Encourage our work. Give us a like. Thanks for watching the video till the end.